Chapter 3, Day 8, Roles and Mean Value Theorems. And this is from Section 3.2, and I mentioned at the beginning of the chapter that we were going completely out of order. Okay, so recall the intermediate value theorem. We discussed this way back in Chapter 1, and it said if a function was continuous on a closed interval, then there exists some x value that takes on every y value in between the beginning and the end of the interval. Now, when you guys were tested on this, I made sure to stress the continuity, because if there's a break in continuity, then the theorem wouldn't apply. So we talked about things like speed, height, weight, being continuous functions, okay? We know that you can't grow to 6 feet without hitting every height before then. Okay, so Rolle's theorem, and this is all on page 172. I would suggest that you at least print out the slides with the theorems on them so you don't have to draw everything with the pictures. Let f be continuous on the closed interval and differentiable on the open interval. If f of a equals f of b, then there is at least one value c in the open interval such that the derivative equals 0. Okay, so let's pick apart this a little bit. Differentiable, you have to be able to find the derivative on the open interval. We know the derivative doesn't exist at an endpoint. That's why it would be open. If the derivative equals 0, graphically, what would this represent? There would be a horizontal tangent line at x is equal to c. Okay, so these are the two functions included in the book. F of a equals f of b, so you start and end at the same y value. On a continuous function, it's saying somewhere you have to have a turning point, and that makes sense, okay, as long as you can find the derivative everywhere. When we look at this graph, there's a turning point. There's a change in direction from increasing to decreasing, but the derivative doesn't exist at this point, so Rolle's theorem does not apply. When we look at this graph, there's nowhere where a horizontal tangent line could be drawn. Okay, so these are the directions when you complete the homework. Determine whether Rolle's theorem applies. If it does, find all values such that the derivative equals 0. If the theorem does not apply, explain why. Alright, so when you guys are tested on this, I become very adamant about checking the conditions. So the conditions of Rolle's theorems are continuity on the closed interval, differentiable on the open interval, and the y value of the endpoints have to be equivalent. So where would a discontinuity occur? At a domain restriction. So yet again, we come back to the domain. The domain of this function is all real numbers, so it's continuous everywhere. To see if the function's differentiable, find the derivative. 4x cubed minus 4x. Domain of the derivative is all real numbers, so it's differentiable between -2 and 2. And now lastly, find the y value at the endpoints. So f of -2, -2 to the 4th minus 2 times 4, we would get a y value of 8. F of 2, and again, it's back into the function, not the derivative. 2 to the 4th minus 2 times 4, we would get 8 again. Get rid of this. Okay, so since the theorem applies, now we can actually answer the question. Find all values of c such that the derivative equals 0. So we already found the derivative equation. So we set the derivative equal to 0. Factoring out of 4x, we get x squared minus 1. So the derivative equals 0 at 0 and plus or minus 1. Now, on the interval from -2 to 2, all three of these values are answers. Okay, so 0, +1, -1. Now, it says to find the value c. If you were to check your answers on CalcChat at this step, so after the theorem applies, they just change the variable to c, and then my answers are still 0 and plus or minus 1. Okay, so don't get caught up in this. You're finding an x value. Okay, so sine of x, we know the domain of the sine function is all reals. So function's continuous everywhere. The derivative of the sine function is positive cosine. Domain of the cosine function is all reals. So it's differentiable. F of 0, the sine of 0 is 0. F of 2 pi is also 0, so the theorem applies. So now we set the derivative, and I'll use c here, equal to 0. Between 0 and 2 pi, the cosine is equal to 0. I should make this a c. At pi over 2 and 3 pi over 2. And that's it. Those are your answers. Okay, domain of this function is all reals, so it's continuous on the interval. The derivative of this function using the power rule, 1/3 x to the negative 2/3. The domain of this function is that x cannot equal 0, so therefore f prime of 0 does not exist. Since 0 is in the interval from negative 1 to 1, Rolle's theorem does not apply. And we're done. Okay, for this function, the domain of this function, x cannot equal 0, and this should be negative 3, comma 3. F of 0 does not exist. It's given in the, 0's in the interval given, so again, can't do anything more. That's why I stress that you check the conditions are met. Okay, so now the mean value theorem. When you see the mean value theorem as opposed to Rolle's theorem, you should think in, we're going to associate this with slope. Okay, so let f again be continuous and differentiable. Continuous on the closed, differentiable on the open. Then there exists a number c such that the derivative equals f of b minus f of a over b minus a. So what does this represent? That's the slope of the secant line connecting the endpoints of the function. Or the endpoints of the interval, excuse me. So look at what this means. We know the slope of the tangent line is f prime of c. So this is saying if the mean value theorem applies, somewhere the slope of the tangent line, here's the tangent line, is equal to the slope of the secant line through the endpoints given. So we know if two slopes are equal, notice that these lines would be parallel to each other. So the tangent line would be parallel to the secant line. Determine if the mean value theorem applies. If it does, then we use the conclusion. Okay, f of x is given. The domain is that x can't equal 0. 0 is not in the interval, so the function is continuous everywhere. The derivative, so if I rewrite f of x as 5 minus 4x to the negative 1, I get 4x to the negative 2. Same domain for the derivative, x can't equal 0. 0 is not in the given interval, so it's differentiable everywhere. Alright, so the mean value theorem, you do not have to check that the endpoints, the y value of the endpoints are the same. That's not a requirement. So this is the conclusion of the mean value theorem. So now we have to set the derivative equal to the slope of the line connecting the endpoints. So my endpoints are 1 and 4. So the slope of the line would be f of 4 minus f of 1 all over 4 minus 1. Alright, so 4 over c squared. F of 4 is 4. F of 1 is 1 all over 4 minus 1. So I'm solving the equation. C squared equals 4. So my solutions to this equation are plus or minus 2, but on the given interval from 1 to 4, the only number that satisfies the mean value theorem would be where C is equal to 2. Now the conclusion of the mean value theorem, the derivative equals the slope of the secant line. Remember what we just did with Rolle's, it was where the derivative equaled 0. Okay, so the conclusions are different for the two theorems. Alright, absolute value, it's on the interval from -2 to 2. That wasn't included. So the domain of the absolute value function is all real numbers. So it's continuous everywhere. But now let's think about the derivative of this function. And this is where we spent some time writing it as a piecewise. The absolute value doesn't do anything if x is bigger than or equal to 1. Alright, any number that you plug in here greater than or equal to 1, the absolute value keeps it, the number inside is the same. If you plug in a number less than 1, then the absolute value takes the opposite of what's on the inside. So the derivative is 1 and -1. So what do we notice here? F prime of 1 does not exist. So since 1 is in the given interval, mean value theorem does not apply. Now you could, we've looked at these so much, we know where the sharp turn occurs, so it's a horizontal shift of 1 unit to the right, and we know that the derivative doesn't exist at the sharp turn. So you don't have to go through the steps of the piecewise, but just so you guys can see it again. Okay, domain of this function is all numbers from 1 to infinity, anything greater than or equal to 1. So it is continuous, it's allowed to be continuous on the closed interval. When we find the derivative, 1/2 x minus 1 to the -1/2 power. The domain of the derivative is now any number bigger than 1. Okay, but it's still, remember the condition, it has to be differentiable on the open interval. So we can proceed. Now the conclusion of mean value theorem, somewhere the derivative equals the slope of the tangent line. Okay, we found the derivative function. And now the slope of the tangent line, 3 minus 1, square root of 2 minus 0, all over 2. So for homework, I want you to solve this equation. Alright, find C such that the derivative is equal to the slope of the tangent line. I'll see you in class.